Hello guys, today we are going to start the second lecture for OSPF. Yesterday's video covers very basic concepts and I hope that before watching this video you have already practiced. If you haven't practiced yet, I will highly recommend you to do practice from the PacketMentor.com. As I recommended you in the hands-on lab section, you do not need to install anything, you do not need any sign up, just go there and start typing your commands and start completing these tasks. This is the quickest way to learn. I mean, if you develop the skills to complete these objectives, then Packet Tracer labs are also available, which help you to make you ready for the exam. Before jumping to the lab, let's discuss few more concepts about the OSPF. One of the most important concepts, link state advertisement. These are basically the messages which are being exchanged during the different states. And through these messages, the network topology is being configured at each router. LSDB is the link state database which carries different LSAs. Then there are some LSAs, router, network, summary, ABR, ASBR. Which router advertise which type of LSA is very important. And during the troubleshooting, it helps you a lot. You need to understand these 5 types of LSAs and what are their purpose. Similarly, there are different type of areas in OSPF. The uniqueness of OSPF or advantage of OSPF among the other routing protocol is the use of the areas, the hierarchical model. OSPF used a big backbone area, by default area 0. Then there are standard areas connected with the area 0. Then there are stub areas, totally stub areas, and not so stubby area. Each area restricts some type of LSAs, which means they restrict some of the messages. The beauty of OSPF is they stop some of the messages, but every router keeps learning all of the network topology. And the last thing for today, which you should understand, is the different roles of OSPF routers. Internal routers mean routers in the same area. Backbone routers are the routers in the area 0 backbone area. ABR, area border router, the router which connects two different areas, for example, area 0 and area 1. And ASBR is the autonomous system boundary router. These are the routers which connect OSPF with another routing protocol, which could be a static routing protocol, which could be a EIGRP or another routing protocol. I have covered this thing quickly because I am expecting that you go to the theoretical section of website and I have covered all these things in detail there. Today's session, the main purpose of today's lecture is to troubleshoot this lab. Let's analyze this lab, what is happening over here. We have configured the similar lab yesterday. In this lab, you can see that I have received a message that I have full neighborship developed with router number 3, but it has not developed any neighborship with router number 2. And let's see the message on router number 3 as well. And router number 3 also did the same thing. So router number 1 and router number 3 have configured the neighborship, but router number 2 has it. So let's analyze the network. So first of all, let's make sure that OSPF is configured at route number 2. Enable show IP protocol. So yes, you can see that OSPF1 is already configured and router ID is given and all the routes. This is the command which allows every connected router that should not be used in the actual environment. Since we are in the lab purpose, so we are using this command. And it's basically saying that every connected router is being advertised. As far as OSPF configurations are concerned, this is not a problem. Then why neighborship is not being developed? Let's analyze the interface level. Show IP OSPF neighbor, no neighbor. Show IP OSPF interface brief. Every interface has assigned a role. G00 considering itself DR. G01 is also considering itself DR. So you can see that they have assigned the role within the OSPF scope, but they are not making neighborship. So let's analyze the same interface on router number 1 as well. Show IP OSPF interface brief. G00 is a interface connected with the router number 2. Both routers are considering themselves as the DR, which means that they are not communicating with each other. Show IP OSPF interface G0/0. Let's see in the detail. So first of all, let's analyze the area. Area is 0. Network address is 1. Router ID is 1. Priority is 1. State DR. Everything looks okay here. Hello timer default. That timer is also default in the broadcast network type. Yes. All the settings looks default here. So I don't think there is any problem with router number 1. So let's analyze the interface. G00 on router number 2. Show IP OSPF interface G0/0. So in this interface, 12.2, area 0, network type broadcast, priority 1, router ID 2.2, all is okay. and the timer hello timer 20. So by default, the hello timer value is 10, and we already confirmed that on R1 default values are configured. So which means that the timer is not same. Therefore, our neighborship between router 1 and R2 is not being established. Let's try to fix this thing first and then analyze that is it the only problem or we are going to face another also. Config T and interface G0/0 IP OSPF hello interval. Let's make it the default. And now you can see that neighborship with router number 1 has been developed and full state achieved. So which means that there is only one problem. At this interface, the hello interval timer was mismatching, therefore the neighborship was not developed, though we have all the configuration totally correct. So this is the one thing which can be tested during the exam. So you should be ready for that. Okay, now let's try to figure out why the neighborship between R2 and R3 is not being established. So the same way, we are going to analyze the interface in detail. Show IP OSPF interface G0/1. So network type is broadcast, cost 1, default value, priority 10, 40. Everything looks okay here to me. I don't see any problem, all the default values. So let's analyze the value in the R3 as well. Enable show IP OSPF interface G0/1. So 23.3 network is okay. Both interface should be in the same network. So network type is network, sub network is okay. Area should be the same. Router ID should be unique. Network type is broadcast, cost 1, priority 1, 3.3, and this also looks okay. So as far as OSPF configurations are considered, I don't think there is any problem. Then why neighborship is not being developed? Let's analyze further. Show IP OSPF interface brief. Show IP route OSPF. Show IP OSPF neighbor. Okay, route 2 is learned via router 1. 2.2.2.2 is learned via 13.0 via this channel, not through 23.3. So this link has some problem. We haven't figured out it yet. So now let's analyze the configuration at the interface level. So in this case, we use the command show running configuration pipe section router OSPF. I don't see any problem here, and let's figure out show run pipe section OSPF. And now you can see that passive interface G01. When you configure a passive interface, it means that hello messages cannot be traveled through this link. If hello messages cannot be traveled, then obviously neighborship cannot be developed. You have to remove this command from the OSPF configuration on router number 3. So how can we do it? We go to the configuration terminal, router OSPF process ID 1. I'm going to select this command, copy, no, and paste. Enter. And write, we'll wait some time, and I hope that if this is the only issue, our neighborship between router number 2 and 3 will be established. Yes, router number 2 and router number 3 have established the neighborship. And now if you see the routing table, show IP route, the 2.2.2.2 OSPF should be learned via 23. Yeah. Now you can see that it is learned via direct connection path. So in this lab, we have seen two problems. There could be some more problem as well. For example, if I create the same router ID of R2 on the router 3 as well, how can we do that? Config T router OSPF1 router ID 2.2.2.2 and write clear IP OSPF process. Yes. And now my OSPF is being reset. This command should not be used at the production environment. This is, since we are in the lab, so we can do these kind of things. So just refreshing, and again you can see that neighborship with router number 2 will not be developed. Why? Because now the router ID on router number 3 and router number 2 have become the same. So router ID should be unique if you want to establish the full neighborship. And another thing, let's create another mess. If I configure config P interface G0/0 IP OSPF 1 area 1. If I move this interface into area 1. Now you can see that there is again mismatch of the area ID. Both sides of the interface should be in the same area. If you don't follow this, your neighborship will be down. So I'm going to remove this command. So again, full neighborship has been developed. So this is how you can make and break different kind of rules, and you can actually learn about OSPF. I will highly recommend you to visit the website PacketMentor.com. This lab is available over there. Download the lab and practice it by yourself. If you want to learn more, please share your thoughts in the comments. I will review all of your comments and answer accordingly. Hope to see you with the next topic. Bye bye.